Hello and welcome back to Instant Seekh. मेरा नाम है कृष्णा कहार. In this video we will be continuing with our UGC NET Computer Science PYQ series. आज के इस वीडियो में हम देखेंगे UGC NET जून 2024 में कंडक्ट हुए ऑफलाइन सेशन के कंप्यूटर साइंस के क्वेश्चंस. आपका जो जून 2024 का ऑफलाइन सेशन कंडक्ट हुआ था जो कैंसिल हो गया था बाद में, उसकी क्वेश्चंस हम देखेंगे. राइट, प्रीवियस ईयर क्वेश्चंस स्टार्टिंग फ्रॉम क्वेश्चन नंबर 1 to question number 50 in this particular part. Okay, so without any further ado, let's get started. Do follow our Telegram channel. इस वीडियो के PDF solutions and as well as other PYQ solution with notes are available on our Telegram channel. So do join that as well. Okay, so let's start. Okay, let's start with the question number 1. What it states: the IO methods in which memory addresses and IO addresses are distinct is called what? Okay, so let's see one by one the options. Isolated IO. Okay, this is also known as port map IO. Okay, where this method uses separate address spaces for memory and for IO devices. Okay, so this is one of the correct option, isolated IO. Memory mapped IO. Okay, in this method IO devices are treated as they are part of the memory. Okay, so here itself the memory address and IO addresses are distinct. Okay, so this is correct option as well. Stop control. This is a method that involves a signal called stop to synchronize data transfer between the CPU and peripherals. Okay, so not an IO method, so this gets eliminated. Handshaking, it is a method used to control the data transfer between two devices using signal controls to ensure proper timing and coordination. Okay, so this is not the correct option. Interrupt, as you know, it is a signal given to the processor indicating an immediate action is required. Okay, so this is not the IO method. Okay, so your correct options are A and B, and this is in your answer option, that is A. So your correct answer is answer A. Let's move on to the next. Okay, match the list question is given. Boolean expression, dual of Boolean expression. Okay, respective Boolean expressions are given. We need to identify the respective dual operation of it. Okay, dual expression form of it. So always remember, whenever we are converting it into dual, so your dot becomes your plus and plus become your dot. That is, your and becomes your or, and your or becomes and, replacing 0 with 1 and 1 with 0. Okay, so this simple you need to remember. If you can see here, replacing and with or with and 0 with 1, 0 with 1. So let's apply this here. X into y plus 0. So it will become x plus y dot 1. So that is option number 2. So A goes here. Let's start with the elimination trick. A goes for second, meaning first 2 gets eliminated straight away. Next, x bar dot 1. So means x bar plus 1. Check for 1 will become 0. Okay, so x bar plus 0. Check for the option x bar plus 0. Here it is, first one. So B goes for first. Okay, can we eliminate? Okay, both have B goes for first. Let's see, check for C. X bar dot y bar plus 0. So this will becomes x bar plus y bar dot 1. That is your option number. That is your option number 3. Right, and last option number D goes for 4. Okay, so your correct pattern will be, see, this gets eliminated, and your correct pattern will be A goes for 2, B goes for first, C goes for third, and D goes for fourth. Your option C is your correct match the pattern for this particular answer. Okay, let's move on to the next. Okay, which of the following is the function of the semantic analysis phase of the compilation process? Compilation process. Okay, of the following, which of the function is involved in semantic analysis? Let's see. First, tokenization. If you speak about tokenization, it is done in lexical analysis. Where? Lexical analysis. Okay. Next, loop optimization, done in code optimization phase. Next, data flow analysis. Data flow analysis is a part of code optimization or intermediate code generation. Okay, so your first type conversion is the part in the semantic analysis. Okay, so semantic analysis check for semantic errors in the code and performs type checking, type conversion, and builds syntax tree. So your option A is your right answer for this particular question. Let's move on to the next question. Number 4. Z is a set of integers. Z group forms group if closure is. Okay. So first of all, you should know what a group is. Okay. A group is a set with an operation that satisfy 4 rules. Which 4 rules? First is closure rule. Closure. Second is associativity. Third is identity. And fourth is inverse. Okay. Invertibility. Okay. Inverse. Okay. So we will check which of these options satisfy all the 4 rules. Okay. Let's start with the option number 1. Okay. So option number 1, define. Okay. First we will check for the closure. Okay. For closure, what it is stating, if you add any two integers and a and b, then add 2, you still get an integer. Okay, right? So this is true. So means closure operation is satisfied. Rule is satisfied. Next, associativity, asterisk a comma asterisk b comma c is same as the given, right? So we can formulate find asterisk b comma c, that is b plus c plus 2. Okay, so if you formulate, so since a plus b plus c plus 4 is equal to a plus b plus c plus 4, that is both the side the conditions are true. Okay, so that's verify the property of associativity. Okay, associative it is. Okay, both the LHS and RHS have the same form. Next, identity, find an element E such that asterisk a comma e equal to a, that is a plus e plus 2 equal to a. If we solve this, e plus 2 equal to 0, which gives us e equal to minus 2. The identity element is minus 2, that is why identity property is also satisfied. Lastly, invertible, for each a, find b such that, okay, a comma b equal to minus 2. So if you solve this, b equal to minus 4, a plus b plus 2 equal to minus 2. Why minus 2? Because here we have whatever identity element, right? So a plus b plus 2 equal to minus 2. So if you solve this, you will get for each a comma b equal to minus 4 minus a is an integer. So invertibility is there. Okay, so all the 4 operations are satisfied. So you can say straight away your option A is your correct answer for this particular question. Let's move on to the next. Okay, which of the following control problem does not exist when processes unaware of each during interaction? Okay, so which of the following option satisfies this? Okay, so your mutual exclusion is your correct answer for this particular question. Okay, that this is the control problem that does not exist when processes unaware of each during interaction. Okay, so this problem, mutual exclusion, resolves around ensuring that only one process access a critical section of code at one time. Okay, so your mutual exclusion is the right answer for this particular question, that is question number 5. Answer is A. Let's move on to the next. Okay, next is the techniques used to handle the phantom problem are. Okay, so first of all, you should know what is phantom problem. Phantom problem occurs in the database when a transaction reads a set of records that satisfy the condition, but another transaction try to insert something that also satisfy the same condition. Okay, meaning what? Let's say you have record something like employee 1 emp1 age is 30, emp2 age is 31, emp3. I'm just explaining the phantom problem first. Okay, emp3 is 28 and there is a transaction t1 that is reading this, that is, you can say select query is fired by this transaction, and another t2 transaction is there which is inserting a record, that is emp4 equal to 35. Okay, So if you, and the condition is for reading the condition is age is greater than equal to 30. Okay, so if you observe, transaction T1 is performing a read operation based on condition what? Age is greater than equal to 30. At the same time, transaction T2 is inserting a record that is satisfying this condition. So this problem is known as phantom problem. Okay. Okay. Now this inconsistency can lead to inconsistent results. Okay. Okay, while inserting we are having the same condition record. So index locking technique and predicate locking techniques are used in phantom. Okay, what? Index locking and predicate locking. Now what are this? Index locking is a technique where locks are placed on the index entries that matches the search condition. Okay, locks are placed. Now where the locks will be placed? Locks will be placed for 30 and 31 because those matches the search condition. Okay, this prevents other transaction from inserting or deleting the rows that affect the result set. Now predicate locking involves locking the entire set of rows that satisfy a condition. This ensures no new rows can be inserted or deleted. Okay, so this index locking and predicate locking. Okay, what does the index locking do? It locks are placed on the index entry that match the search condition, whereas in predicate it involves locking the entire set of rows that matches the given condition. Here the indexes are set of indexes entries are locked. Here the entire set of rows that matches the condition are locked. So your correct answer is B and C. The techniques used to handle the phantom problem are index locking and predicate locking. That is your option number B. Okay, let's move on to the next. Techniques for performing IO. Okay, techniques for performing IO are what? Programmed IO, yes. Interrupt driven IO, yes. Rotational IO, no. Rotational IO term does not correspond to any IO technique. Okay, so this is wrong. DMA, yes. Direct memory access is also there. Channelize IO, no. Wrong. Okay, so only three, A, B and D are the valid option or valid techniques for performing IO. Okay, so your option B, that is A, B, D only, is the correct answer for this particular question. Answer B. Let's move on to the next. Okay, arrange the following from fastest to slowest in speed. Always remember what matrix is given. These are the memory components. Okay, and it is asking us to arrange it from fastest to slowest, and the matrix is speed. Sometimes they give you access time, loading time. Okay, so first read the question properly and then start arranging. Okay, so here we are asked to arrange it with respect to speed, starting on from the very fastest. Okay, so very fastest is your what? CPU registers with respect to speed. Then comes your SRAM, or you can say static RAM. Okay, then comes your dynamic RAM, DRAM, then your hard disk, and at last the slowest ones are magnetic tapes. Okay, so the correct sequence will be from fastest to slowest with regards to speed will be C, CPU registers, then your SRAM, that is option B, then your DRAM, that is option A, then hard disk, option E, and then your magnetic tape, that is option D. Okay, so C, B, A, D, that is your option. Answer option B is your correct answer for this particular question. Let's move on to the next. The ratio of error found before software delivery and to the total errors before and after is called what? Okay, the ratio of error found before software delivery and to the total errors, that is before and after including both, is called what? Is called defect removal efficiency. It is called what? Defect removal efficiency is a measure used in software engineering to quantify the effectiveness of defect detection process. Okay, it is calculated as the ratio of defects found before delivery to the total defect or to the total defects, that is both before and after. Okay, so how it is given? It is given as defect removal efficiency is equal to defects found defects before delivery divided by total errors, or you can say defects total errors before and after. Okay, so your defect removal efficiency is the ratio of error found before software delivery to the total errors. Okay, so your answer is option number C. Let's move on to the next. Okay, the chair of an auditorium are to be labeled with a letter followed by a positive two-digit integers, where labeling is starting from with A01. Labeling is starting from A01. Okay, the chairs of the auditorium in a certain auditorium are to be labeled, okay, with a letter followed by two positive digit integer, where labeling is starting with A01. How many maximum possible chair could be labeled in that way? Okay, so how many we can label? Okay, so let's say how many letters we have in English? Okay, we have 26 letter, right? A to Z. Okay, we need to identify how many maximum possible chairs could be labeled in this way. Okay, then we have two digit positive number. Okay, so the range will be what? It will be the range 0, 1 to 99, right? This is the possible range it can be. Okay, so we have the number of letters for how many? 26. Okay, and we have number of two digit integers, how many? 99. So simply we will multiply. Okay, and if you multiply, you will get your answer, that is 2570 number of ways we can arrange the chairs in the auditorium, or we can label them. Okay, so your correct answer is option number B, that is 2574 ways to label the chairs. Okay, so your answer B is your right answer. Okay, let's move on to the next. Okay, next is question number 11. The output of the following C++ program. Okay, int main is there. We have integer variable and an integer pointer. X equal to 30. Okay, we have an integer variable int x and an integer pointer p. Okay, x equal to 30, p equal to x, printf %d comma asterisk p, and return 0. Okay, so first of all, you should know whenever we are assigning the pointer, it should be we are assigning a reference. Okay, it should be something like this: p equal to %x. Okay, not p equal to x, not this way. This is wrong. Okay, so your answer will be error. That is your option number D. Okay, not C, not A, not B. Error will be the output of this particular code. Okay, because whenever you are initializing pointer, okay, whenever you are attempt to assign value, okay, then it will generate the error. You should assign the reference memory address to an integer variable reference. Okay, so let's move on to the next. Okay, fuzzy sets are given. For the fuzzy sets, a is what? X1 comma 0.3, x2 comma 0.7, x3 comma 0.4. Okay, and b we have x1 comma 0.5, x2 comma 0.2, x3 comma 0.4. 5. Okay, so what it is saying, the A intersection B would be what? Okay, A intersection B would be what? So for intersection, we find the minimum membership value, that is min, right? So minimum value we just need to identify. For x1, what is the minimum value here? If you compare both of them, so it will be 0.3. For x2, it will be 0.2, and for x3, it will be 0.4. So the correct answer will be x1 comma 0.3, x2 comma, okay, this bracket, x2 comma 0.2, and x3 comma 0.4. Okay, so which of the following option? Yeah, your option number D matches this particular pattern. Okay, so answer is option D. Next, the cardinality of a fuzzy set is finite. Straight away you can mark finite. The cardinality of a fuzzy set is finite, refers to the number of elements. Basically, what do you mean by cardinality? It is what the number of elements in the fuzzy set. In a fuzzy set, the cardinality is the sum of the membership values of all the elements. And since all the number of elements is finite, the cardinality of a fuzzy set is also finite. So your answer is option number B. Let's move on to the next. Okay, an ambiguous grammar is one which has what? More than one derivations, more than one leftmost derivation, more than one rightmost derivation, more than one parse, more than one syntax tree. Okay, so let's see one by one. Okay, an ambiguous grammar is one which has more than one leftmost derivations. Okay, and more than one leftmost, more than one rightmost derivations. Okay, that is your B and C only is your correct answer for this particular question. Okay, your ambiguous grammar is the one which has more than one leftmost derivation and more than one rightmost derivations. Okay, so let's move on to the next one. Okay, mathematical modeling question. Arrange the steps involved in mathematical modeling. Okay, so one by one we will see solution, formulation, solve, mathematically, repeat, interpretation. Okay, so first of all what we do is formulation mathematically, formulate mathematically, then we solve mathematically, then we solution fitting with the data is considered, then repeat the formulation if it fit worst with the data, and at the last interpretation of the results. Okay, so the correct sequence will be first we formulate mathematically, then we solve mathematically, then solution with the fitting data, fitting with the data is identified, that is option A, then repeating the formulation if it fit worst with the data, that is the option D, and at the last interpretation of the result. So the correct pattern is B C A D E. Okay, that is your option number A is your right answer. Let's move on to the next. Okay, next is an IPv4 packet has arrived with the first few hexadecimal digits as shown below. How many hops can this packet travel before being dropped? The data belong to the upper layer protocol. Okay, so the starting initial few hexadecimal digits are shown to us. Okay, so determine the TTL is located. Okay, so if this is the pattern 54000018001001100406001. Okay, so the given is the sequence. If you see, the TTL is located at the 9th byte of the sequence IPv4 header. In this provided sequence, the 9th and the 10th digits are 04. Okay, so again I am repeating, the time TTL field is located in the 9th byte of an IPv4 header, isn't it, right? So to convert in this sequence, if you see the 9th or the 10th digits, so those are 0 and 4, 0 and 4. See, let me convert this to byte wise group. Let's say this becomes 1, 54, then 0, 0, then 0, 0, then 1, 8, right? Then 0, 0, then 1, 0, then 0, 1, then, okay. Did we missed anything? Okay, yes, we missed one. Okay, let me correct it. Yeah. So after 1, 8, we have what? After 1, 8, 1, 8, we have 0, 0. Okay. After that, 1, 0, then 0, 1, then 1, 0, then 0, 4, then 0, 6, then 0, 1. Okay. So this is the pattern. So if you see, the TTL field is located on the ninth byte of the IPv4 header. So if we count 1, 2, 3, 4, 5, 6, 7, 8, and at ninth byte we have the code that is 04. Since this is hexadecimal, so if we convert in, this is hexadecimal, right? So if we convert it in decimal, it will be, decimal will be 4 itself. Okay, 4 itself, 4 is the decimal. So this indicates what? This indicates the packet can travel 4 hops. How many hops? 4 hops. Now why it is? Because the time to live field indicates the particular timing sequence. Okay, so the protocol field is located at the 10th byte of the IPv4 header, and the protocol bit is 06. Okay, see last 06, that it consider it is a TCP connection. Okay, so if you want to know, the ninth bit is the time to live, that gives us the number of hops converting from hexa to decimal. So this becomes your number of hops, and the protocol field is your 10th field. Okay, this one, if you are not able to see this, this is 06. Okay, so 06 indicates what? It corresponds to 06 correspond to TCP. The protocol is TCP. Okay, so your correct answer will be 4 hops, and the upper layer protocol will be TCP. That is your option number D is your right answer for this particular question. Let's move on to the next. Okay, the sequence of fields in an IP datagram will be, okay, with regards to IPv4, you should be able to know TCP IP, TCP OSI module, IPv4 header, the entire header sequence. Okay, so let's see, coming back to this particular question, what will be the sequence of field in an IP datagram? So the first and foremost is your service type. Okay, next will be your identification field. Next is your flags. Next, protocol, and at last are the options. Okay, so the correct sequence will be service type, that is option A, identification, option D, flags, option A, then flags, then protocol, option C, and then options, option B. Okay, so this will be the correct sequence of field in an IP datagram. That is your option number A. Okay, so option number A matches the pattern of sequence. Okay, so option A is your correct answer. Let's move on to the next. Okay, match list question, matching the list 1 with list 2. Okay, choose the correct answer. So first is given bit oriented channelization protocol, bit oriented protocol, random access protocol, controlled access protocol. Okay, so you should know Aloha is what? Aloha is very well known for random access protocol. Okay, so your option C goes for first. Your option C goes for first. Let's try to eliminate. Okay, option C goes for first, so these two gets eliminated straight away. Next, your TDMA. TDMA is what? The time division multiple access. Okay, is a common channelization protocol. It is what? A channelization protocol. That is your option A. Okay, let's see if we can eliminate this as well. That is, A goes for 2. Okay, so A goes for 2, so option D gets eliminated. Okay, so A goes for 2. Now, bit oriented protocol, this is related to HDLC, that is high level data link control. Okay, it is a bit oriented protocol. Okay, so option B goes here, and your option D, control access protocol, is going for reservation method. Okay, that is for what? Control access protocol. So your correct pattern is A goes for second, that is channelization protocol is what? TDMA. B, bit oriented protocol is HDLC, right? Next, random access protocol, Aloha, and control access protocol is your reservation. Okay, so option B is your correct option from the given sequence. Okay, let's move on to the next. For line drawing algorithm, for line drawing, which of the following algorithms are used? Okay, so for from your computer graphics, this is the question. So which of the algorithms are used? You should know DDA is one of the algorithm that is used for line drawing, right? Bresnan is also Bresnan line drawing algorithm. Midpoint is related to circle, right? Midpoint is for circle and ellipse. Okay, so this gets eliminated. Curve, as the name suggests, it is for Bezier curves. Okay, so option A and B only are your right answer. That is your option C. Answer C is your correct answer for this particular question. Let's move on to the next. Okay. Which of the following structures of knowledge representation are mostly purely syntactic? Okay, so let's see. Okay, one by one we will see. Conceptual dependency. Conceptual, it captures semantic relationship. Okay, meaning it incorporates syntactic elements like roles and case relation. But is it purely syntactic? No. Okay. Next, predicate logic focuses on the structure of propositions and logical connectives. It defines value argument based on syntactic rules regardless of the specific meaning of the symbol. So it is purely syntax level based. Okay, syntax. So it is purely syntactic. Slot and filler. Slot and filler represent knowledge as entities, that is objects, and attributes. Slots filled with values, that are fillers. It emphasizes the structure of the knowledge representation. Okay, so this is also one of your correct option. Last, non-monotonic system deal with reasoning and inference. Okay, so this is eliminated. This gets eliminated. So both predicate logic and slot filter prioritize the structure and the organization of knowledge representation, making primarily syntactic in nature. Okay, so these two, that is B and C, are your correct structures in knowledge representation that are purely syntactic. B and C, that is your option number B, is your correct answer for this particular question. Let's move on to the next one. Okay. For regular languages and context-free languages, which is not correct? Okay, first let's see what are those. Regular languages are closed under which condition? Okay, so regular languages are closed under union, concatenation, intersection, and complement. And CFLs, context-free languages, are closed under union, concatenation, clean star, not closed under interaction or complement. Okay, so let's see one by one. Both are closed under union operation. Both are closed under union operation. Yes, this is correct. Okay, this is correct. Both are closed under concatenation operation. Yes, if you can see here, both are closed under concatenation operation. Yes, this is also correct. Both are closed under intersection operation. Regular languages are closed under intersection, but CFLs are not. Okay, so this is incorrect. Both are closed under complementation operation. Regular languages are, but CFLs are not closed under complement. Okay, so this is also incorrect. both are closed under knee star operation. No, this gets eliminated. Okay, so your option E, B and E gets eliminated. Those are correct ones, but gets eliminated here because we are finding the incorrect ones. So the both closed are closed under intersection operation is false, and both closed under complementation operation is also false. So your option C and D only is your correct answer. That is your option number C is your correct answer for this particular question. Let's move on to the next. Okay, the number of tokens in the following line, okay, for I in range begin, okay, colon and colon step colon is what? Okay, you need to mention the number of tokens. So first of all, you should know the line given in Pythons. The tokens are parentheses, identifiers, okay, all those are termed as tokens. Okay, so if you count this, tokens given in the above are, first is for, right? So this becomes 1 I, 2 in, 3 range, 4, okay, then comma is there, 5 parenthesis, 6 begin, 7 colon 8 and 9 colon, okay, 9 step 10 parenthesis 11 and again colon is 12. Okay, so there are total 12 tokens in this. If you are not able to see that clearly, I will write it down again. For I in range, okay, parenthesis begin colon and colon step parenthesis and again colon is given. Okay, so every identifier or this operator or parenthesis are count as tokens. So this is your first token, 1, then 2, then 3, then 4, then 5, then 6, okay, parenthesis, fifth one is parenthesis, then 7, then 8, then 9, then 10, then 11 and then your 12. So total number are 12. That is your option number D is your correct answer for this particular question. Let's move on to the next. The sequence of steps for a page replacement algorithm will be what? Okay, so for whenever we do page replacement algorithm, what is the sequence? So let's start first. No frame is free. Option number D. Next, find a frame that is not currently being used. We need identify those frames. Then we do what? Free a frame. We will try to free a frame for allocation purpose. Okay. After that, we change the page table, and after that we will use the empty frame that we have recently emptied. Okay. Freed. Use freed frame. Okay. So the correct sequence will be, so first is no frame is free. That is option number D. Next, find a frame that is not currently being used. Okay, unused frame. Okay, it is, even though it is not free, but it is not been currently used. Okay. Next, we do what? Free that particular frame. That is option number E. After that, change the page table. Okay, option B, and at last use the freed frame. That is your option C. So this is the correct sequence of steps involved in a page replacement algorithm. Okay, so your from the below option, your answer A is your correct answer for this particular question. Okay, so let's move on to the next one. Match list, matching the list 1 with list 2. Okay, we have backtracking. Okay, infinite languages with matching numbers, canonical LR parser, post correspondence problem. Okay, so let's match. So backtracking refers to predictive parser. Okay, refers to what? Predictive parser. So A goes for 3. So if you try to eliminate straight away, you can see option D is none of the option as A 2 3. Okay, then too we will see the other option as well. Infinite languages with matching numbers. So this goes for automata. That is option number 1 goes for B. Okay. C goes for 4. That is canonical LR parser. It acts on large number of set. And post correspondence problem is undecidable problem. Okay. So your backtracking, first of all, is a method used in solving constant satisfaction problems like puzzles and other recursive algorithms scenarios. So the correct match is predictive parser. Correct match is predictive parser. Infinite languages with matching has a these pretend to languages. Option B, this pretend to languages that have infinite number of string often deal with automata theory. Okay, so this goes here. Canonical LR parser is an efficient bottom-up parser that can handle large and complex grammar, but generates a large number of states. Okay, so C goes here. Post correspondence problem is what? It's a well-known undecidable problem. Okay, so A goes for third, B goes for first, C goes for fourth, and D goes for second. Option D is your correct matching option for this particular question. Let's move on to the next. Which of the following is not correct about the virtual memory segmentation? Okay, which of the following is not correct? It is not necessary to load all the segments of a process. It is necessary. This is wrong. Okay, it is necessary to load all the segment of a process. It has no internal fragmentation. Again, it has no internal fragmentation. It has internal fragmentation. Okay, so this is also a true case, but not as with we are finding incorrect one. Okay, it has virtual address space. Yes, it has virtual address space. This is correct. This gets eliminated as well. It provides lower degree of multi-programming. No, it not provides lower degree of multi-programming. That's why this is the false statement. Okay, this is incorrect. This is our option. This is the answer for our particular question. That is, which of the following is not correct about virtual memory segmentation? Okay, so it provides lower degree of multi-programming. This is incorrect because virtual memory segmentation actually allows higher degree of multi-programming, not lower degree, by enabling more processes to reside in memory. Okay. Okay. So your incorrect option that we need to identify is option number D. Is your correct answer for this particular question. Let's move on to the next. Okay. Now we have match the list question again. So let's see. First one, this represents a rule is given. This represents a rule in context-free grammar where A can be replaced by either AB, right? A can be replaced by either AB or A. This type of rule is suitable for finite automata, where it is suitable finite automata. So it goes for option number 4. Next, this represents a rule in context-free grammar where A can be replaced by B, C or A, right? This type of rule is suitable for Chomsky normal form. So option B goes for the third one. Let's try to eliminate. A goes for 4. A goes for 4. So straight away these two gets eliminated. B goes for 3. Okay, both are going. B goes for 3. Okay, next LL1 grammar is a type of context-free grammar that can be passed by a recursive descent parser. So option number 1 goes for C. Let's try to eliminate. Okay, this gets eliminated and we have our correct pattern here. Halting problem is a Turing machine problem. Okay, so A goes for A goes for 4. That is your finite automata. B goes for rule that can be well handled by Chomsky normal form. C goes for first recursive descent parser and D goes for Turing machine. That is your option number 2. So your option A is your right match the option for this particular question. Let's move on to the next. Multiple inheritance is permitted directly in which of the following languages? You should be knowing which languages support multiple inheritance. Java, straight away, it doesn't support. Let's eliminate. Okay, VB, does it support? No. Basic, no oops concepts were there. Okay, so C++ and your Python is supporting what multiple inheritance. Okay, so your A and C only, that is your answer option B is your correct answer for this particular question. Let's move on to the next. Arrange the following in correct order so that they can follow a proper runtime environment. Okay, so let's try programming statement, compilation, memory allocation, type of variable, memory deallocation. Okay, so you should know memory deallocation will be performed at last. Okay, so let's start. Programming statement, yes, this is the first correct step. Okay, proper run flow. We start with a certain programming statement, then we do the compilation, right? Then we have type of variable, identification of the type of variable, and accordingly memory allocation, that is option number C, and after that memory deallocation. Okay, so your correct order or proper runtime environment will be A, programming statement, then B, compilation, then D, type of memory, then C, memory allocation, and then E, that is memory deallocation. So your option pattern will be A, B, D, C, E. That is your option, answer option D is your correct answer for this particular question. Let's move on to the next. Okay. Which of the following genetic algorithm operation is computationally most expensive? Okay. Which of the following genetic algorithm operation is computationally most expensive? Okay, convergence testing, initial population creation, selection of sub population for mating, or reproduction to produce next generation. So your costliest will be, or your expensive operation will be reproduction to produce next generation. Okay, see, reproduction to produce next generation is a process in genetic algorithm where new offsprings are generated through crossovers and mutation operations. And this step is computationally intensive because it involves multiple operations such as selecting of parent individual, performing crossovers to generate new offspring, and applying mutation operations. Okay, to introduce variability. So your option D, reproduction to produce next generation, is what computationally most expensive in genetic algorithm operation. Okay, so option D is your right answer. Let's move on to the next. Okay, next we have which of the following are true for a complete binary tree. Okay, it has always odd number of vertices. Does it has it? This is incorrect. A complete binary tree can have an odd or even number of vertices. Always odd? No. So not a valid statement. Next, in complete binary tree with I internal vertices, it has I plus leaf. Yes, this is true. In a complete binary tree with I vertices, it will have I plus 1 leaves. Next, with L leaves, it has L minus 1 vertices. Same the reciprocal of the above statement. If you have L leaves, let's say your vertices were 4, internal vertices were 4, and then you have leaves how many? 4, that is I plus 1, that is 5 leaves. And if I am saying I have 5 leaves, then how many vertices I will be having? L minus 1, that is 4. So this is also correct statement. With 2 raised to n minus 1 vertices, it has n leaves. So 2 raised to n minus 1 vertices, it has n leaves. This is wrong, incorrect. So your correct option statements will be B and C. That is your answer option B will be your correct answer for this particular question. Let's move on to the next. Okay, question number 31. How much time does an algorithm using 2 raised to 50 bit operation need if each bit operation takes 2 raised to 38 minus 38 second of time? Okay, so to determine how much time an algorithm using 2 raised to 50 bit operation needs if each bit takes 2 raised to minus 38 second, we can follow the steps. Okay, so the total time will be basically equal to number of bit operation. How many bit operations are there? Okay, the bit operation is 2 raised to 50 multiplied by time per bit operation, and what it is given, time per bit operation is 2 raised to minus 38, 2 raised to minus 38. Okay, so if you evaluate this operation, so it will be 2 raised to 50 minus 38, that is 2 raised to 12, 2 raised to 12. And if you compute 2 raised to 12, it will give you 409 seconds. How many? 409 seconds. Okay, now if you divide this by 60, it will give you how many minutes. Okay, we are converting it to minutes and hours. Okay, so it will give you around 68.27 minutes. 68.27 minutes. Again, I am repeating, total time is given by what? Number of bit operation and bit time per bit operation. Okay, simply we multiplied and we get an equation. We are now converting it to what? Time value, that is seconds. Now we have converted into minute, and if you try to convert this in hour, okay, it is greater than, slightly greater than 1 hour, so we can mark it as was option. We can mark 1.5 hour is your correct. Approximately we can mark, since it is coming more than an hour. Okay, it is coming greater than 1 hour. Okay, so your correct answer for this particular question will be option number D, that is 1.5 hours. Okay, so the closest appropriate answer. Let's move on to the next. Which of the following statements is or false? Okay, so let's see. Which of them are false? A user can assign privilege to any user on any relation. Straight away it is false. This statement is false. A user can assign privilege to any user on its own relations only. Yes, this is true. A system error that leads to accessibility to the portion of database is an example of malicious attack. Yes, this is also no. This is also a false statement. Okay. Now why it is false? Okay. A system error leading to unintended access is basically a security vulnerability, not accidental exposure or accidental exposure rather than a malicious attack. Malicious attack implies internal actions by an attacker, whereas accessibility error that leads to accessibility is basically more of a kind of what, unauthorized access kind of error. Okay, so this is false. Password itself needs to be secured from unauthorized access. Yeah, this is true. So your only false statements are statement A and statement C. That is your first option. Answer option A is your correct answer for this particular question. Let's move on to the next one. Lower triangular sparse matrix is one which in which all the non-zero elements lie on the leading diagonal. No. In which all the non-zero elements lie above the leading diagonal. No. In which all non-zero elements lie below the leading diagonal. Yes. In lower triangular matrix like this one. Okay. So all the non-zero element lie below the leading diagonal line. Okay. Non-zero element means what? If you have a matrix, so it will be something like this. Okay. Hence all the, so this you can state it as what? Lower triangular sparse matrix. Well, all the non-zero elements lie below the leading diagonal. Okay. So other gets eliminated. So your correct answer is option number C for this particular question. Let's move on to the next. Okay. Question number 34. Arrange in appropriate order the construction of finite automata. How we construct the finite automata. Okay, to arrange the construction of a finite automata, let's understand this sequence first of all. First and foremost, that the step is problem statement. Okay, first is problem statement. The step is to clearly define the problem that needs to be solved. This involves the understanding the requirements and constraint. Now the step number 2 is the regular expression. Regular expression. Once the problem is defined, the next step is to represent it using regular expression. Okay, a concise way to describe the language of the problem. After that, after defining the regular expression, it is converted into non-deterministic finite automata with Elfson transition. Okay, so third, this becomes your third step. After this is done, the NFA is then converted into DFA, that is your deterministic finite automation. Okay, and after this, finally the DFA is minimized to produce a minimum state DFA which has the least number of state required to recognize the same language. So this comes at your last. So your correct pattern will be D, problem statement, then D, converting it the problem into regular expression. Okay, that is option number B. Next, C, converting into NFA, that is non-deterministic finite automata, option C. Then converting it into DFA, that is option E. And then converting into minimum state DFA, that is option A. So D, B, C, A will be your correct option, appropriate order for the construction of a finite automata. That is your option, answer option B is your correct answer for this particular question. Let's move on to the next. Which of the following is not a characteristics of specialized embedded OS? Okay, which one of the following is not a characteristics? Okay, real-time scheduling policy, yes, this is a characteristics. Respond to external interrupts, yes, this is also one of the characteristics. Provide special non-sequential file, no, this is not the characteristics of specialized embedded OS. Provide fixed and variable size partition, yes, this is also a characteristics. Okay, so your answer will be option C. Provide special non-sequential files is not a characteristic of a specialized embedded OS. So answer C is your correct answer for this particular question. Let's go on to the next one. Okay, next, the height of a binary search tree for the words banana, peach, apple, pear, coconut, mango, and papaya using alphabetical order is So we need to construct the BST, okay, based on the alphabetical pattern. So let's try. So insertion rules are what? We will insert the words into BST one by one according to BST insertion rules. So first we added the word, okay, banana here. Okay, banana we have added. After that, height equal to 0 since it is the only node, and root, insert peach. Okay, so peach we have inserted now, peach. Okay, next insert apple. So since A comes before B, so apple will go this side, apple. Now we have pear. Okay, so insert pear after at the this side, peach side. Okay, so pear goes here. Next we have insert coconut. Okay, so coconut will come here, coconut. So now the height to coconut is the left child of peach. Okay, now insert mango. So mango goes here. Okay, after that insert papaya. So papaya goes here. So the height of the resulting binary search tree, if you see, is 1, 2, 3, and 4. Okay, so the height of the binary search tree for the words is option number C, that is 4. 4 will be the height for this particular binary search tree. Okay, so answer is option number C. Let's move on to the next. Yeah, match list 1 with list 2. We have read levels and what are their respective operations. Okay, so read level 2, as we know, read level 2 is used for error correcting code, so option A goes here. Read level 3 is basically for what? Bit interleaved, so option B goes here. Let's try to eliminate from the options. A goes for 2, A goes for 2, so this 2 gets eliminated straight away. B goes for 4, so this gets eliminated as well. Okay, read level 4 is basically for block interleaved, and read level 6 is for read Solomon codes. Okay, so your correct matching pattern will be A goes for 2, that is read level 2 goes for error correcting code, read level 3 goes for bit interleaved. Okay, C, read level 4 goes for what? Block interleaved, and D, read level 6 goes for read Solomon codes. So correct, so your correct matching option pattern will be option number B will be your right answer for this particular question. Okay, let's move on to the next. Okay, arrange the following examples of artificial intelligence AI in the order of increasing complexity. Okay, in the order of increasing complexity, we need to arrange. Spam, okay, I will mark as per the increasing order itself. Okay, so first, spam email, handwritten, digit recognition, image classification, autonomous. So from this, first spam email is what? The lowest complexity. Handwritten, digit recognition, image classification, autonomous driving. Okay, so handwritten goes for second. Handwritten, digit recognition using shallow neural networks, image classification, and autonomous driving. You can straight away mark the most difficult one is autonomous, so this goes for 4, and the image classification goes for 3. So your correct sequence will be spam email detection using rule-based system. Okay, has the lowest complexity, then your handwritten digit recognition, then comes your image classification, and then your D, that is autonomous driving. So this will be the increasing complexity pattern of for the examples of AI artificial intelligence system mentioned below. Okay, and the correct option that matches is your answer. Option A is your correct answer for this particular question. Let's move on to the next. Okay, what is the total delay latency for a frame size of 10 million bits that is being set up on a link with 20 routers, each having a queuing time of 2 microsecond and a processing time of 1 microsecond. The length of link 500 kilometer. The length of the link is 500 kilometer. The speed of the light inside the link is 2 into 10 raised to 8 meter per second, and the link of the bandwidth is 6 Mbps. Okay, we need to calculate the total delay or latency for a frame size of 10 million bits. Okay, so let's go through this. So first of all, frame size is given, that is frame size. Let me write it down. Frame size is given to you. Frame size is 10 raised to 7, that is 10 million bits, that is 10 raised to 7 bits. Okay, then the number of routers is given 20. Queuing time per router is given what? 2 microsecond. Okay, then processing time per router is given as 1 microsecond. Okay, then length is given. Length, we have length of the link is what? 500 kilometer. Speed of the light inside is 2 raised to 8. Okay, so first of all we will calculate for C total queuing delay. We should have what? We should have the transmission delay, propagation delay, total queuing delay, and total processing delay. All these 4 components we should know for what? For total delay. What I said, first we should know is transmission delay. Okay, TD. then you should know propagation delay. Okay, then you should know queuing delay, and then you should know processing delay. It is mentioned by this PR delay. This will give you total delay, TD. Okay, so transmission delay, how you can calculate transmission delay is basically frame size. TD is basically frame size divided by link bandwidth. Link bandwidth. Okay, so what is the frame size here? 10 raised to 7. Okay, divided by link bandwidth is what? Link bandwidth is given you 6 Mbps, right? Here 6 Mbps is given, so that is 6 into 10 raised to 6. Okay, so if you calculate, we will be getting 1.6667 seconds. Okay, that becomes your TD. Let's calculate processing delay, PD. Oh, sorry, propagation delay. Okay, PD is equal to what? It's equal to length of the link, that is your 500 kilometer, 5000 kilometer, and we can mention it like this: 5 into 10 raised to 6 meter per second. Okay, so propagation delay equal to length of the link divided by speed of light. What is the speed of light? 2 into 10 raised to 8. So if you calculate this, you will be getting 0.025 seconds. Okay, let's calculate queuing delay. Queuing delay is what? Queuing delay is equal to number of routers and queuing time per router. What is the number of router? 20, and queuing time per router is what? Your queuing time is 2 microsecond, right? So, and processing time is 1 microsecond. So the number of routers into processing time per router, that is, okay, actually it will be processing time, number of routers into your this. Okay, we are calculating this queuing delay, no? So it will be number of routers into queuing time per router, that is your 2 microsecond. We can write 2 into 10 raised to minus 6. Okay, and this will give you 40 microsecond, and that you can write it as 0.0004 times 0 and then 4. See, for actually for queuing delay, you multiply the number of router by queuing time, and for propagation delay, okay, sorry, for processing delay, you multiply the number of routers by the processing time per router, and that is 1 into 10 raised to 6. So that is the difference. So here you will get similarly 0.00004 times 0 and 2 seconds. Okay, so now let's place all the values. TD we have got what? 1.667. So here I will write 1.6667 plus, okay, we have propagation delay. What is the propagation delay? 0.025 seconds, right? Then we have queuing delay. Queuing delay is 0.4 times 0 and 4, and processing delay is 0.4 times 0, 2. So if you add up all this, you will be getting 1.69176 seconds. Okay, so this will be your total delay, okay, for this particular question. Okay, so your option number B is your right answer for this particular question. Answer D, option B is your right answer, that is 1.691726 seconds. Okay, so let's move on to the next one. Okay, the following code: statement, then if expression, then statement else statement, or if expression then statement, suffers from which type of condition? Okay, so it is basically suffering from the condition that is ambiguity. Okay, now what is ambiguity? Ambiguity is a grammar that means there is more than one parser tree or leftmost deviation for the same string produced by the grammar. In this case, the ambiguity arises because it is unclear to which if and else should be matched. Okay, because to which if the else should be matched. Okay, so that is the ambiguity here. And where there are nested if then without explicit, okay, without explicit braces indicate the block structure. Consider, okay, so we have the expression. Let's write the expression so for we can have a better understanding. If expression 1, if expression 1, then if expression 2, okay, continuing, then okay, not them, then statement else statement. Okay, so this will be your what, the considered input string. Okay, there are two possible ways to interpret this. The else is associated with the nearest if. The else is associated with the nearest if. Okay, so this else is associated with the nearest if, that is expression 2, and this interpretation will be as follows. Okay, so as follows means if expression 1, then it will be like this: if expression 1, then if expression, then statement else statement. Okay, basically a clear case of ambiguity, okay, confusion. Okay, so straight away you can mark your correct answer, that is option number A, the case of ambiguity. Let's move on to the next one. Okay, the actual, okay, question number 41. The actual parameter actual count is used in genetic algorithm for selecting population. For what? For selecting population. The parameter actual count is used in genetic algorithm for your selecting population. That is your option number C is your correct answer. Now, actual count is in used for selecting the population, and refers to the process of choosing individual from the current generation to be parent for the next generation. Okay, and what are the other terms? Crossover is what is a genetic operator used to combine genetic information of two parents to generate a new offspring. Okay, so that is crossover. Mutation introduces random changes to individual genes, which helps to maintain genetic diversity, okay, within population. So that is mutation. And encoding in genetic algorithm involves representing the solution to the problem in a particular pattern, often as a string of bits or characters. Okay, so the parameter, coming back to the question, the parameter actual count is used in genetic algorithm for selecting the population. So option C is your correct answer for this particular question. Let's move on to the next. Okay, next is the for making a memory size of 2048 into 8 bytes by using the chips of size 128 by 4 bytes, the number of chips required is, okay, we need to calculate for making a memory of size 204 or 8 by 8 bytes by using the chips of size 128 by 4 bytes, the number of chips that will be required of size this is the how many number. Okay, so let's first determine step by step. We will calculate total memory size. Total memory size total memory size is given as 2048 into 8 bytes, right? 2048 into 8 bytes, and if you convert this into bits, so it will be what, 2048 into 8. So this will give you 131072 bits. Okay, you can keep it in bytes as well, but I am converting in bits for calculation purpose. Okay, now determine the total chip size in bits. Now we will determine the total chip size. What is the chip size here? 128 chip size. Okay, chip size given is 128 by 4 bytes, and if we want to convert it into bits, then we will multiply it by 8. So 128 into 4 into 4 into 8, and this will give you 4096 bits. Okay, now straight away a simple division you need to perform. So the number of chips required, number of chips that is required will be total memory size, that is total memory size in bits, that is 131072 bits, divided by the number of chips available, number of chip size in bits, that is 4096. Okay, and if you want more simple, so you can use this too for cancelling out simplifications, that is 2048 into 8 into 8 divided by 128 into 4 into 8. So 8 get cancel out, 4 ones are, 4 twos are, right? And straight away you can calculate this. If you divide this 128 16s are, so 16 into 2, that is you will get 32. 32 number of chips will be required for making a memory of size 2048 into 8 bytes. Okay, so your correct answer will be option C, that is 32 number of chips will be required. So answer will be answer C. Let's move on to the next. Which of the following is not the most common property in social network? Okay, so let's see. Degree distribution follows scale free. Okay, this is one of the property. Average shortest path lengths are shortened in connected network. Okay, this is also a common property in social network. Most of them are directed network. No, this is false. This is not a most common property in social network. Follow small world property. Okay, this is also one of the property. Okay, so most of them are directed. Most of them are directed is the correct answer for this particular question, because if this means that if a person is connected to the person B is also connected to person A, representing mutual relationship. Okay, directed networks represent relationship where the connection is always one way. Remember this. Social network is what? Social networks are always undirected. If a person is connected to B, then person B is also connected to person A. Okay, and directed networks means relationship where the connection is one way, such as Twitter. One user can follow another without reciprocation. However, this is less common in general social networks like Instagram or something. There, if someone is following something, then both of them gets connected. Now they have barrier. Let's put that example aside, but you got the point, right? If for social networks are undirected and your directed networks, there is always one way communication. Okay, so here most of the network are directed. This is not a common property in social networks. So your option C is your correct answer for this particular question. Let's move on to the next. Shift reduce conflicts are resolved by what? Your shift reduce conflicts occur in parsing where the parser cannot decide whether to shift, read more input, or to reduce or apply a grammar rule based on the current input stack. Okay, so that is what shift reduce conflict is. Okay, so these types of conflicts are basically resolved using associative and precedence rules. Okay, so where the shift conflict reduce occurs in parsing where the parser cannot decide whether to shift, read more input, or to apply a grammar rule based on the input, then this associativity and precedence rules dictate how the operators of the same precedence are grouped in the absence of parentheses. Now, what is associativity? Associativity determines how operators of the same precedence are grouped in the absence of parentheses, and precedence determines order in which different operators are applied. That is, multiplication has higher precedence and then addition. Okay, so Your correct answer is option number D. Using associativity and precedence rule, shift, reduce, conflicts are resolved. Okay, so answer D is your correct answer. Let's move on to the next. Okay, regarding the subroutines, see the following sequence of tasks to be performed. Okay, subroutine, your microprocessor and microcontroller, right? So let's see. Turn on the interrupt facility, service the device, save the contents, check the flag is set, restore the contents of the processor. So you should start. So first, we always start with saving the contents of process register, current register. Okay. After that, we check which flag is set. Okay, which flag is set. After that, we service the device whose flag is set. Okay. After that, we restore the content of process register. Okay, and again we turn on the interrupt facility on. Okay, so your correct sequence is first save the contents of process register, that is option C, then check which flag is set, that is option D. After that, service the device whose flag is set, that is option B. Then restore the content back of the process register, that is option E. And at the last, again turn on the interrupt facility, that is option A. So your correct sequence pattern will be C, D, B, E, A, that is your option number C will be your correct answer for this particular question. Let's move on to the next. Okay, list 1 and list 2 are given. Function. Okay, let's try with the easier. Union is what? User defined data type. Straight away this goes for 4th, right? So let's see, we can eliminate. Okay, A goes for 4, so this 2 gets eliminated. Now function is nothing but a subroutine. Okay, so option 3 goes for B. So from this, now you can eliminate this as well. Okay, so your option A will be your correct pattern. Interactive environment is what? Interactive environment is virtual reality, and output device is a shadow mask. Okay, so if you are able to guess any two, so you should be able to eliminate and choose the correct option. Okay, so option A goes for 4, that is union is a user defined data type. Function, option B goes for 3, that is function is a subroutine. Interactive environment refers to virtual reality, that is C goes for 1, and uh, D goes for 2, that is D goes for 2, that is shadow mask. Okay, I hope we have done right. Yeah, A goes for 4, that is user defined type. B goes for 3, that is function goes for subroutine. C goes for first virtual reality, and D goes for second, that is your output shadow mask. So your correct matching pattern option will be option A. Okay, let's move on to the next. Which of the following are sequential circuits? Which of the following are the sequential circuits? Okay, so sequential circuits, first of all, we will see flip-flop. Yes, it is a sequential circuit. Next, multiplexer. Multiplexer is a combinational circuit. Okay, that selects one of many inputs and forwards the selected input into signal line. Okay, so this is a combinational circuit, not a sequential circuit. Then counter. Yes, it is a sequential circuit. It is that goes as a sequence of states. Okay, then we have a decoder. Decoder is also a combinational circuit, not a sequential circuit. Okay, that contains a, okay, that takes convert binary information from n inputs line to 2 raised to n input line. Okay, adder is also a combinational circuit that is used for adding binary number, and it does not store any state information, hence it is not a sequential circuit. Okay, so your only correct circuits are A, flip-flop is a sequential circuit, and counter is a sequential circuit. That is A and C, that is your answer. Option B is your correct answer. Let's move on to the next. Okay, in genetic algorithms crossover operation, mask is used in which type of crossover? Okay, so we need to tell that. Okay, in genetic algorithm crossover operation, mask is used in which operation? It is used in uniform crossover operation. Now, what is uniform crossover? It is a genetic algorithm crossover where a mask is used to determine parent will contribute each gene to the offspring or not. Okay, so a uniform crossover is a crossover operation where a mask is used to determine which parent will contribute each gene to the offspring. In this crossover method, a binary mask of same length as the parent chromosome is generated, where each bit in the mask decide the parent form from which the gene will be taken. Okay, so let's say suppose if bit is 1, the gene is taken from the first parent. If the bit is 0, then the gene is taken from the second parent. Now what are the other option? Three parent crossover involves three parents but typically uses a different approach. Okay, selecting the median value of genes. Okay, two parent crossover other and n parent crossover are the other type of crossover but do not typically use mass. Okay, instead they use specific points on the chromosome to decide where to split and exchange the segments between parents. Okay, so your correct answer is crossover uniform crossover, that is option number C, that uses a mask to select which determine which parent will contribute each gene to the offspring. Okay, so option C is your correct answer. Let's move on to the next. Okay, arrange the following sets in increasing order on the basis of their cardinality. Okay, so question number 49, this is on their cardinality. Let's arrange the sequence. Now cardinality is basically the number of element it has. So first one has how many elements? Two, one set and the three. Okay, two sets are there. Here it has four elements. Next it has one element. Next it has three elements, and last it has five elements. Okay, so what will be the correct sequence? That will be A3, A1, okay, A3, A1, then your A4, then your A2, and then your A5. Okay, and what will be the sequence? A3 is what? C, A1 is A, A4 is D, A2 is B, and your A5 is E. So this will be the increasing order on the basis of cardinality. Okay, so remember what is cardinality? It is the number of elements, and the number of elements, okay, we have identified the element and basis on that increasing order we have arranged it. Okay, so your correct sequence will be CADBE. CADBE, that is your option number D. Option number D will be your correct answer for this particular question. Okay, let's start with the question number 50. Which of the followings are tautology? Okay, following are the expressions given. Okay, so first of all, let us formulate the truth table for this particular all these expressions. Okay, so I have formulated the truth table. We have P, Q, negation of P, P or Q, P and P or R. Sorry, I'm again and again I'm saying Q, P R, then negation of P, P or R, P and R, P then R. Then we have negation of P then R. Okay. So first, what are the options? So your this is your option A. Okay. This is your option B. This is your option C. This is your option D, and this is your option E. Okay, and by seeing you can now state which of the followings are true, or you can say tautology, and which of them are false. Okay, so if you see option A and option B are false, right? They doesn't result in tautology, whereas C, D and E results in what? Toto or complete tautology pattern. Okay, a tautology is basically where a formula that is true for every possible interpretation. So for C, D, E, it is true. All the interpretations are true. So these are tautologies. Okay. So your option C, D, E is the correct expressions for this, and your correct option is option number D is your right answer for this particular question. Okay, simple tautology you need to. Okay, students, with this, we complete our first part of this UGC NET June 2024 computer science paper. Starting from question number 1 to question number 50, we have seen. In the next part, we will be seeing the questions from question number 51 to question number 100. Do join our social media handles, WhatsApp, Telegram, and Instagram. And do join Telegram, where all the notes and PDFs are uploaded on our Telegram channel. Do like and share this video, and also do not forget to subscribe to Instant Seekh channel for more such videos. Okay, thank you and keep practicing. Jai Hind.